Which of the following isomeric trienes is the most stable? So before we start this question, I just want to make sure that we understand the terminology that's in this question. So when we say isomeric, all this is telling us is that all of these trienes, all of these molecules have the same molecular formula. They are isomers of each other. So they are isomers, they have the same molecular formula. So this just means that we are comparing things that are similar enough when we're being asked this question. And you would know at this point in time actually what type of isomers these are. These are all connected together differently, so these are all constitutional isomers. Okay, so in this case. Okay, so isomeric could tell you any different type of isomers. They could also be stereoisomers, but in this case, they're connected together differently, so they are constitutional isomers. So when we're evaluating the stability of a molecule with more than one alkene, the first thing we want to look at is where those alkenes are relative to each other. So these are polyenes. So if we're looking at polyene stability, the most important thing we're going to look for is conjugation. So conjugation means having alternating single and double bonds. And so why this is important is that this allows for electron delocalization. So alternating single and double bonds. Because this gives us, as I just mentioned, delocalized electrons. And having delocalized electrons is associated with lower energy. So that's the first thing we're going to look for. So if we take a look at A here, we've got one isolated alkene. So isolated means that it's separated from the other alkenes by at least one sp3 hybridized carbon. So this one is isolated. And we'd recognize that by seeing this sp3 carbon that kind of interrupts this pi system. And then these other two alkenes, we've got two of these that are in conjugation. So you've got two conjugated alkenes here. If we look at B, we have sp3 hybridized carbons that are interrupting all of these alkenes. So we actually have absolutely no conjugation. These are all isolated. If we look at C, we have double bond, single bond, double bond, single bond, double bond. All three of these are conjugated. So here we have three conjugated alkenes. This is looking pretty stable. If we're dealing with trienes, this is probably as good as it's going to get, right? And then here in D is somewhat similar to A, where we've got one isolated alkene, because we've got this sp3 carbon in the way. So this one here is isolated. And then at the end, we have these two that are in conjugation. So here we have two conjugated alkenes. Okay, so we've got our most stable one here. If we had a scenario where we had two options where they both had the same number of conjugated alkenes, then you would look to the next factor, which would be substitution. So you'd look for that conjugation first, and then the second thing you would look for is substitution. So if you had two of these that had the same number of conjugated alkenes, then you would say, okay, the one that's the most conjugated and the most substituted would be the more stable.